All right, this video is on exponential and logarithmic applications. Just some more word problems to expose to you. If you're intrigued, this is from 4.5, and pre-cal, it is from 3.5, okay? They bring back exponential growth and decay, which we saw with money earlier on this chapter, and we saw it as PERT, okay? In this section, they express it differently. I just want to show you the comparison, how they're the same thing with different variables, okay? So A is still amount. A sub O, that little sub O stands for original. It's a subscript, right? Like the opposite of an exponent. And A sub O, or the P, stand for the initial amount. The E is still the function E. Rate can be represented with an R, and sometimes they put a K. That is a rate. Make sure you put that as a decimal. And T is still time. So taking a look at this first question, it says, a small preserve has an initial population of 14 deer. Okay, so what's 14? You can call it A sub O, you can call it P, okay? I just want to make sure that you feel confident with it. And it grew to 20. What is that? My A. It grew in 4 years. This is my time. Find the growth rate. They're asking me for R. Or K, depending on whichever one you look at, okay? So let's set up with a new equation just so we practice it with both. A equals A sub O times E raised to K times T. Okay? My total amount is going to end up being 20 deer. They started off as 14 deer. I don't know my rate, but I do know that it took 4 years. Okay? My end goal should be to get that K by itself. What's my first move? Divide the 14. So now I'm going to have 20 over 14 equals E raised to 4K. Now, if you plan on being a student in my AP class in the future, I'm going to encourage you not to even touch that 20 over 14. Something within us wants to reduce it. But when you are taking a heavy-duty test that is timed, you want to save that brain energy. Leave it as a 20 over 14. Don't take the chance of making a mistake, okay? What should I do next? Good. Remember, I can ln or log, but the PERT question specifically has an E. So the ln is going to work out really nice. Okay? And this will move to the front. So I'm going to come up here. Now we have ln of 20 over 14 equals 4k times ln of E. What does ln of E equal? 1. 1 times anything is itself, so that ln of E is technically going to disappear. And what is my last step to get k by itself? Divide by 4. So I could say k equals ln of 20 over 14, all divided by 4. Okay? If you don't like fractions within fractions, you can also write this as 1/4 of ln of 20 over 14. And at this point, you are going to your calculator to find me what that rate is. So when you put that in your calculator, it should look like this. Make sure you are in radian mode. So you get that K is 0.089. And remember, actually I'm going to put an equivalent sign because I am taking off some decimal points from my calculator. And what would that give me as a rate, as a percentage? 8.9%. Okay. So logistics growth gives you a more realistic view as to how exponential growth works. So exponential growth, we talked about, grows forever from left towards right, all the way up. Okay. But when we start talking about reality, I cannot go to the past. I can't go back in time. So we don't worry about negative time. And if we talk about, for example, a population of like deer, how we saw earlier, if I put a couple deers on an island, they will start to multiply and grow, 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 grow. But there'll come a point where they're going to start growing at a slower rate. Maybe there's not enough food on the island for that many deer. They don't fit. They start maybe dying out. And there will be a growth limit. Okay? So the exposure to this in pre-cal is as simple as giving you a scenario with the equation given. You won't learn how to create and work with that function for logistics growth until calculus BC. Okay? So looking at this question, it says, the logistics equation models the number of people who are infected with a virus. How many people will be sick by the second week if T is given in weeks? So all you have to do, if it says by the second week, is plug a 2 into your function and then plug it into your calculator. So pause if you need to for a moment to do that. If you plugged it in, it should look something like this. And you should get 476.28 people. We can't really have 0.28 of a person. So my answer here is roughly 476 people will be infected. Okay. All right. So let's look at these last few questions that we have here. This next part is just a rewrite. It's not much to solve. It says expressing an exponential function with a base of e. Okay, so the reason we're allowed to do this is, do you agree that e raised to ln equals 1? We talked about that the other day. Okay, so if I input right here an e raised to ln, it doesn't change its value. Okay, now the next question you might be asking yourself is, why is the x no longer an exponent and why is it being multiplied? Well, if I put an e raised to ln, now this b goes up to an exponent. And do you remember the rule from algebra? What do you do with an exponent raised to an exponent? You multiply. So that's why these two are being multiplied, okay? So for this one, it says rewrite this function with a base of e. You're going to just input an e raised to ln here, and I can say y equals 3.82 times e raised to ln of that 6.7. And you can write the x in the back or you can write it in front of the ln. Okay? And again, you're not solving anything here. You are just rewriting a function. Cool? All right, let's move on to our word problem. Okay, 2 more practice questions. Nothing new here. Slide 11 says, if the initial population of squirrels in a city is 30 in 2000 and grows to 38 in 2001, what information did they just give you? Right, so here's initial, and here's the total amount. What else did they give you? Time. What is time? Right, from 2000 to 2001, time is 1 year. And then what is the growth rate? They're either asking you whether you want to call it R or K. So my equation says total amount equals initial amount times the function e raised to kt. Plug in what you know. Okay. T is 1, so that makes that really easy. What's my next step? Divide the 30. What's my next step? Apply an ln to both sides. Good job. Okay, and then that k will move as a coefficient. So I will have ln of 38 over 30 equals k times ln of e. What does ln of e equal? 1. So 1 times k will just give me k. So now go ahead and plug that into your calculator. Pause for a moment if you need to. And if you plugged it in, make sure you're in radian mode. It should look something like this. 0.2363. So K is approximately 0.2363. And if I want to represent K as a rate, as a percentage, it would be 23.63%. Okay. All right. And let's take a look at this last one. All right, our last question for today. If the function given models a flu infecting a school population, how many students will be sick in 2 weeks if T is measured in 2 weeks? So this, believe it or not, is one of those super easy questions. They tell you T is in weeks, and they tell you 2, so all I have to do is plug in a 2. So take a moment and plug that into your calculator, and let's see what you get. All right, if you plugged it in your calculator, it should look something like this. You should get 84.55. We can't have 0.5 of a person, so we would say that 84 people, approximately, were infected. All right, that's it.